This is CPM Calculus, Chapter 2, number 56. Okay, so we have this guy or girl, Zuhaib. Zuhaib is anxiously waiting for the results of his calculus test and is pacing back and forth as shown in the graph at the right. So he's walking. So to note is we have time here as seconds, and on this axis we have feet. Distance, okay? So he's walking back and forth. He's starting at a distance of 1.8 or so feet. He gets up to walking toward, I don't know, six-ish feet. Goes down back to the distance of 1 point something feet, and then walks up again. Okay? So part A is saying at which point we have point here, 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 and here is his speed the greatest. So approximate the rate. Okay, so speed, the distance, remember speed is equal to distance over time, right? So we're not multiplying, find the area, we're dividing, right? We're looking at from here to here, the change in feet divided by the change in time. So we're looking at the rate. Okay, so we're not looking at the area, we're looking at kind of the change in feet over the change in time. Okay, so we're going up, 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 up. It looks like a constant speed going up. Then he stops, he walks a little bit, and he goes back, 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 back. I guess so he's probably walking forward, right? And then he stops, no movement, then he walks back, up, turns around, walks forward again. Something like that, okay? So, where is he going the fastest? It looks like where the slope is steepest, right? Here, he's going faster than here. Here, it looks like he's going faster than there and here. So, I would say at C, okay? So, at point C, Zuhaib speed is the greatest. Okay, so how do we approximate the rate? So we kind of have to look a little bit to the left and to the right. So this is kind of hard with a small graph like this, but it's just approximated. So we could look here. Oops. Let's see, at 8, it looks like it goes up to 8, it goes up to 4 maybe, so that's 8 comma 4 there. And 7, it looks like it goes up to 6, yeah. 9, it goes up to, I don't know, I would say 2. Okay, so I want to look at those points, and the change in, again, the speed is the change is equal to change in distance over change in time. So remember, the distance is the y value, so I could pick 2 points. I'm going to pick a point here and a point here, right? So if I go 7, right, I said it's around 6. I'm eyeballing it, so it's approximately. So I want to make sure I use approximately here. Well, here at least. Okay, because here it's definitely equal to that. I want to change the speed, so I'm going to say his speed goes from 6 to 4. 6 minus 4 divided by change in time, it goes from 7 to 8 seconds, right? So I'm going to say 8 minus 7, because we know we're going 2 feet in 1 second, so it's approximately 2 feet per second, okay? That's his time. I mean his speed. Well, okay. Okay. Yeah. Okay. So I approximated his speed to 2 feet per second. Now, how do we do, so that's part A, okay? Part A is done. At which point is his velocity the greatest? Okay, so I'm going to look at velocity. So what's the difference between, oh, they're asking that in question C. So let's start with C. Because they're asking about velocity and speed, I want to know the difference so I can answer that one accurately. Because I know the speed is greatest here at point C, right? The difference between velocity and speed. So remember, velocity is a vector and has a magnitude. So our magnitude of velocity is speed and direction, right? So speed doesn't have direction. So it doesn't matter which direction you're going. So speed is never negative, right? Yes. But velocity can be negative. So this is kind of like a physics problem. When he's going at first, he's going away, right? His distance, remember this is distance and this is time. His distance is increasing. It kind of stays the same. It increases a little bit and it decreases, right? And then it increases. Well, we know a decreasing distance over time is going to be a negative velocity. So it can't be C. So it's either, well, B, it looks pretty flat. Doesn't look like he's changing. A or D. I would say, as earlier, I would say this is steeper over here. Okay? So now I'm looking at part B. I'm doing them in the opposite order. But what point is Zuhaib's velocity the greatest? His velocity, right, because it has direction, magnitude and direction, is greatest at point A. Approximate the rate. So the rate we know is, so V is equal to our change in distance over change in time with direction. So we know it's positive here, or it's away from his starting point. And we could pick 2 points. So I'm going to pick 3, 5 and 2, 3. What is that? 1, 3. Okay, so picking those 2 points, they're like on the same slope as A. So the change in distance we know is the y value. So I'm going to go 5 minus 3. The change in time, we're just going from 1 to 3 seconds. So 3 minus 1. So we get 5 minus 3 is 2 over 3 minus 1 is 2 is 1 foot per second. Okay, so his velocity is 1 foot per second, and remember it contains direction. So I want to say away, where is he going? Back and forth. So away, the direction is away from the initial position. Because it's asking for velocity specifically, I want to make sure I include some direction. So 1 foot per second or 1 feet per second away from the initial position. Okay? And again, velocity is a vector from part C and has a magnitude and direction. Speed doesn't have a direction, never negative. Velocity can be positive or negative. Right. Okay? Because when you are, yeah. This ends CPM Calculus Chapter 2, number 56.